So let's talk about something that felt like total science fiction just a little while ago. Running a truly powerful AI, the kind you interact with online, but right there on your own machine. For the longest time, that was just a pipe dream. But what if I told you the game has completely changed? The hardware you actually need for local LLMs, well, it's not what you think.
You've probably seen this everywhere online, right? If you scroll through forums or Reddit, the message is loud and clear. If you don't have a dedicated beefy GPU, don't even bother. It's been the unspoken rule, this huge barrier to entry for so many people.
But here's the thing. With all the breakthroughs happening, like every single week, you have to stop and ask, is that really still true? Has the game finally changed for those of us who want to run AI on our own terms with the hardware we already have? Okay, before we get into the nuts and bolts of CPUs and GPUs, let's back up a second and talk about the why. Why is everyone suddenly so obsessed with running AI locally? It really all comes down to this super powerful idea, sovereign AI.
So what's the deal with this sovereign AI push? Well, it breaks down into 4 really important things. First up, data confidentiality. Think about it. Are you really comfortable sending your most sensitive private information to some third-party cloud service? Probably not. Then there's cost control. You can say goodbye to those heart attack-inducing usage-based cloud bills. Next is sovereignty, which is really just about having full control over your own systems and your own data. And finally, customization. Imagine being able to fine-tune a model on your private data for a task that no public API could ever handle. That's a game changer. All right, with all that in mind, let's dive into the first path to local AI. And you might want to brace yourself, because this is the path that almost everyone has written off for years. Running these powerful models on the CPU you likely already own.
So how on earth is this even possible? Well, it's thanks to 2 key innovations, a framework called llama.cpp and a technique called 4-bit quantization. Now think of quantization like this. It's like taking a massive high-resolution photo and compressing it into a much smaller JPEG. Yeah, you lose a tiny bit of imperceptible detail, but the picture looks basically the same. Quantization does that for AI models, shrinking them down by about 4 times, which means they can actually fit into your computer's RAM and run directly on the CPU. It's pretty incredible. And look, this isn't just a theory. The proof is right here in the numbers. Let's break this chart down. We're looking at 3 CPU setups, a total dinosaur from 2013, a standard modern laptop i7, and a brand new server CPU. Now the speed is measured in tokens per second. Just think of a token as a small piece of a word. The higher the number, the faster the AI feels. And what's wild is that even on that old 2013 chip, a pretty decent 7.6 billion parameter model is chugging along at 8 tokens per second. On a modern laptop, you're getting 15. That is absolutely fast enough for a real-time conversation.
This is the new reality. One of the research papers put it perfectly. This speed is more than enough for a basic chatbot. So let's just put that old myth to bed, okay? The idea that you absolutely cannot run an LLM without a GPU is, well, it's officially dead. For a whole lot of single-user applications, your CPU is all you're going to need.
But what if you need more? More speed, more power. Maybe you need to serve multiple users at once. Well, that's when we graduate to the big leagues. That's when we talk about the dedicated GPU. For anyone who's chasing raw performance, a powerful consumer-grade GPU is really the only way to go. We're talking about a beast of a machine that's built from the ground up to handle the kind of massive parallel math that LLMs thrive on. It delivers a level of performance that, frankly, will just blow your mind.
But just how good are we talking? Well, take a look at this. This chart shows scores on MMLU, which is a major benchmark for general knowledge. Those blue bars? Those are the cloud-based giants, the big models with massive data centers behind them. And that orange bar? That's an open-source model running on a single consumer GPU. And it's scoring 83%, right up there with the big guys. So who says you need a whole data center to compete?
So let's just sum it all up. CPU only is your cost-effective, use-what-you've-got option. It's perfect for personal projects and moderate use. But if you're chasing top-tier speed, serving multiple people, or you want to run the absolute biggest and best models out there, a GPU is non-negotiable. It's the classic showdown, really. Cost versus pure, unadulterated performance.
Okay, so we've covered the hardware. But once you've got your setup, how do you actually know how good your model is? How does the whole AI community measure and compare these things? This is where benchmarks step onto the stage and become the supposed ultimate yardstick for performance. You've seen these everywhere, I'm sure of it. Leaderboards just plastered with these ridiculously high scores from all the big names.
You've got MMLU for general knowledge, GPQA for super tough reasoning, SWE bench for coding. These scores have become the currency of the AI world. It's how models get judged. But are they really telling us the whole story?
Because this obsession with topping the leaderboards, it has a really dark side. There's a hidden trap here that's leading almost everyone astray, and it could be giving you a completely wrong idea about what a model can actually do.
Think about it. What happens when the test itself is broken? When the very ruler we're using to measure everything is fundamentally flawed from the start? This problem actually has a name. It's called benchmark leakage. And honestly, the best way to think about it is like giving a student the answer key before a final exam. Of course they're going to ace the test. But did they actually learn the material? No way! They just memorized the answers. And the result is a completely bogus, inflated score that means absolutely nothing in the real world. This is a classic textbook case of something called Goodhart's law. It basically says that the second a measure becomes the main target, it stops being a good measure. The pressure to get that #1 spot becomes so intense that gaming the system is the only thing that matters.
So here's the bottom line on why you've got to be skeptical. First, you have saturation. When all the top models are scoring above 90%, how can you possibly tell which one is actually better? Second, contamination. You never really know if you're seeing true intelligence or just a really, really good memory. And third, you've got straight-up gaming the system. The labs are under so much pressure to win that they're basically teaching to the test.
So if the public leaderboards are basically useless, how in the world are we supposed to figure out which model is right for us? Don't worry, there is a better way, a much more reliable way, a way that actually puts you back in control.
Here is your 5-step plan for building an evaluation system you can actually trust. Step 1. Map your use case. What do you really need this model to do specifically? Step 2. Go ahead and pick 2 or 3 public benchmarks that are at least relevant, just as a starting point. Step 3, and this is the most critical part, build your own private test set using your own data. Step 4. You need a human in the loop. Have a person spot check the outputs to catch all those subtle mistakes an automated system would miss. And finally, Step 5. Treat your evaluation like a product. Keep track of it, version it, and improve it over time. This quote just says it all, doesn't it? Public benchmarks are a one-size-fits-all t-shirt in a world where everyone needs a custom-tailored suit. What you really need is a bespoke test that measures what actually matters to you.
So, as we wrap this up, I want to leave you with this one thought. The public leaderboards are a circus of inflated scores and misleading claims. The real question you have to ask yourself is this: what score will your model get on your problems? Because at the end of the day, that's the only benchmark that truly matters.